So we've been given a vector of length 4 with a direction of 50 degrees, and we've been asked to write this vector in component form. And so again, I like to draw this out. No matter how you slice it, no matter how complicated someone tries to make it, basically every vector can be broken into either magnitude and direction or components. So either they're going to give you the components and ask you for magnitude and direction, or they're going to give you the magnitude and direction and ask you for components. This is a right triangle trig problem. It is very, very simple if you understand it that way. And so in this case, I've been given the magnitude, which is the hypotenuse. It's 4. And I've been given the direction, which is 50 degrees. And I've been asked to find the x and y components. And so if I throw all these fancy words, component form, magnitude, direction, if I throw those all out, what I really have is I have a right triangle. And I told you this is 4, this is 50, and I want you to find x and y. I want you to find x and y. Okay, and so I look and I say, okay, well, if I want to find x, it's the adjacent side, and 4 is the hypotenuse. Adjacent and hypotenuse make a fun little equation. It's called cosine. Cosine of 50 is adjacent over hypotenuse. How do you solve this for x? Just multiply by 4. So 4 cosine of 50 is the adjacent side. And I can take my handy dandy calculator as long as I'm in degree mode, and I can type 4 cosine of 50 and I get 2.57. Okay, and the same thing here, I can take this y side. I can say, okay, let me same thing, this is opposite, this is hypotenuse. Opposite and hypotenuse, that's a sine equation. So I say sine 50 degrees equals opposite over hypotenuse. Again, solve this. You end up with 4 sine 50 equals y. And you can solve for y. 4 sine of 50. And I get 3.06. Okay, if I round these to 2 decimal places. So there's x and y respectively. And so then the last step is to write this in component form. Component form of a vector is always going to have these pointy brackets, and that's going to tell you that this is a vector and not a point on the xy coordinate system. Okay, and so there is our answer, 2.57 and 3.06. Now, not necessarily the only way to write this. They could ask you for an exact answer, although typically with an angle like 50 degrees, you don't get such a pretty answer, because the exact answer would be this. It would be 4 cosine of 50 and 4 sine of 50. But if they ask you to round it to 2 places, you would just use these answers here. If they ask you to round it to 3 places, you'd give extra decimals. My calculator will give me 9, so I can go anywhere between no decimals and 9 decimals. But that's component form. And if you want to check, if you really want to make sure, well, did I get this right? Did I get this right? I mean, yeah, it's great for you to watch a YouTube video and see this and say, oh, well, this guy told me to do it this way. But how do you know you got it right? Especially if you're sitting in an exam, or goodness gracious, let's say you're a structural engineer or an architect, and you know this is your job, and you kind of have to know which way these forces are going and how hard they're pulling. One of the ways you can check this is the components are going to be the legs of the right triangle, and the magnitude is going to be the hypotenuse. And so Pythagorean's theorem should work. And so I take 2.57 squared plus 3.06 squared, and then I take the square root of that answer, and I get 3.99, which less a little bit of rounding is equal to what? 4. So you can always check these answers and see that they work just using Pythagorean's theorem. So if you have any questions about that, component forms of vectors and that sort of thing, please let me know.